Today, let's continue our journey to space by discussing the weather, its origin, causes, and formation. This knowledge is particularly essential not only for academics but for all of us because the effect of weather is universal and it makes sense to know about what affects you as a human, most especially the things that can sometimes affect you negatively. So this is treated in plain language to carry everybody along. So let's start. So what do you consider good weather? Is it cold, sunny, warm, or dry? The answer to these questions vary from human to human, as this will depend on individual preferences, which is anchored on feelings, current environment, and even commercial considerations. For instance, I will always prefer cold weather because I already have more than enough hot and dry weather as a resident of tropical region. However, the weather varies from day to day, location to location, and region to region. The question now is, what is weather? In simple language, weather is the state of the atmosphere, describing the degree to which it is hot or cold, wet or dry, calm or stormy, clear or cloudy. We are able to experience the weather that we are in now because we are in a trapped environment called atmosphere. The question is, what is atmosphere? And are we really trapped in the atmosphere? What is that uncomfortable feeling? The answer is yes. We are trapped in the atmosphere, but we are only trapped in the layer of the said atmosphere, which is the only one known to support life in the entire universe. Good. So, atmosphere is a blanket of gases that surrounds Earth. The atmosphere consists of various gases, water vapor, clouds, fog, wind, and so on. At this point, it's important to let you know that atmosphere consists of 5 distinct layers, so we are not exposed directly to any harmful object that may fall from space. They are, from the top to the surface of the earth, exosphere, thermosphere, mesosphere, stratosphere, and troposphere. Now, while exosphere is about 10,000 kilometers, that is from 700 to 10,000 kilometers to the surface of the earth, the closest, which is troposphere, is just about 0 to 12 kilometers to the surface of the earth, and that's approximately 7 miles. So the image above shows the layers as explained, and you can easily appreciate the way they are all lined down in a spherical form, since the earth is also a round object. In one of the earliest videos I made, I have treated all these layers in details. You may wish to check it out in the link below. However, here I will limit my discussion to only the troposphere where we live and exist. The second reason is that there is a boundary between the troposphere and the next layer, known as tropopause. This tropopause traps all moisture, gases, and water vapor in the enclave of troposphere. So we are comfortable treating only troposphere since it's the only one that is supporting us. So what are the contents of troposphere, our home? The composition of tropospheres is 78% nitrogen, 21% oxygen, then the rest, starting from carbon dioxide to argon, to methane, to water vapor, the rest is just the 1% that is remaining. So you can see, when I said it supports our existence, you will appreciate what I've said. For instance, for respiration purposes, we use oxygen, and of course, we breathe out carbon dioxide, which the plant requires for its own growth. If you see what I've written clearly, you will understand and appreciate that the atmosphere already contains what we require for respiration and plants to survive. Having established our container, now let's look at how weather is formed and what is responsible for differences in weather from point to point on the Earth's surface. Causes of weather: temperature difference and altitude. The biggest factor that causes weather on the Earth's surface is a temperature difference due to the altitude. Differences in the degree of coldness and heat of particular area on land and sea. Now, how did this issue of temperature come into being? Now, remember, our giant star, Sun, is there to provide us with the solar radiation required on daily basis. But the truth is, while it is doing that, it is not being controlled by any force rather than for the rotation that made it available at one portion of the earth at certain time and make it available at the other time. So, this explains why we have day and night. So, the implication of this is that the heat is not uniformly distributed, and of course we shall begin to discuss this as lecture continues. So when the sun, finally hit the earth's surface, most especially in the day, it does that by hitting both land and sea. Land, of course, is able to evaporate, because if you hit a particular surface, what you expect is an evaporation of the content. So for land evaporates quickly more than the sea, because of course seas are water and ocean as well are water. And you can experience this in the afternoon. If you board a flight, you discover that at certain points there will be more bumpy ride, and you'll be wondering that it is afternoon and you may not be able to even physically see why that is so. I am talking about if you want to land, because you must be very close to ground to experience this. The air coming out as a result of solar radiation starts to ascend and get replaced with cool air. The reason being that it is less dense, and the process will continue as long as there is a presence of the source of the heat, in this case the sun. So rising air being cool will be responsible for the condition of weather as we ascend the Earth's altitude. Hence, the higher we go, the cooler it becomes. At every 1,000 feet above the Earth's surface, there will be a corresponding reduction in the temperature by 2 degrees. And the implication of this is, if I start with a 20 degrees centigrade on the Earth's surface, by the time I get to 20,000 feet, I must have exhausted all the little temperature I have. So I'll be tending towards -2. Atmospheric pressure. Do you know that air has weight? In fact, we are technically being pressed down by the weight of the air around us. Every square inch of the surface of our body feels 15 pounds pushing on it because of the air in the atmosphere. Luckily, this pressure is cancelled out by the principle of laws of motion in physics, mainly because the pressure is applied to every space within the object on the Earth's surface. So all of this, simply cancelled out. Air pressure is the pressure exerted by the weight of air above us. At sea level, it is roughly 14.7 pounds per square inch. This means that a column air of 1 square inch in diameter, extending all the way to the top of the atmosphere, weigh 14.7 pounds. For measurement in millibars, the standard pressure is 1013.2 millibars. Also remember that as the air begins to rise during the process of evaporation, it becomes less dense and the molecules are far apart. Therefore, the pressure will be getting lower and lower. Hence, the higher you go, the lower the pressure. For example, for every 1,000 altitudes in your journey, the air pressure decreases by 1 inch mercury, which is approximately 34 millibars. So, as you begin to go up, you feel less and less pressure because the air is less dense. The wind. Another factor that affects temperature is the wind. So what causes wind on Earth? Exactly, what causes it is just sun as well, When sun unevenly hit the Earth's surface, air rises and sinks, resulting in high and low region of air pressure. As air rises, the pressure lowers and surrounding air moves to replace it. So you begin to have something very similar to a circular motion. So the air in the atmosphere, which is now in constant motion, generally the air is densest when it is close to the surface of the Earth, and the density decreases as altitude increases. There are differences in gradients throughout the Earth's surface because of high and low areas. We have mountains, we have valleys, and so on. So this gradient on the Earth's atmosphere creates areas of different temperatures and moisture. All of these items you have are the content of air masses as well. Okay, let me define air mass. An air mass is any volume of air that moves about the Earth. And of course, this one can greatly vary in size. So you can, imagine an air mass like a chunk or a bundle of air moving together with the same characteristics. And this one they do by moving from one place to the other. Winds are currents of air that moves across the Earth's surface and develop when two adjacent air masses have different densities. So the movement of air masses above the Earth's surface help to create wind and help to move the air masses that predict our weather. The wind help to shape the atmosphere and affects weather pattern from the upper atmosphere to the ocean surface. At this juncture, let me introduce a concept known as Coriolis effect and force. In physics, the Coriolis force is an inertial or fictitious force that acts on an object in motion within a frame of reference that rotates with respect to the inertial frame. In a reference frame with clockwise rotation, the force acts to the left of the motion of the object. And of course, in the anti-clockwise rotation, the force acts to the right. So let me illustrate this by showing you the way Coriolis effect happens. And it's better, illustrated using a disc or a rounded object. The forces that affect wind pattern. Because of the Earth's rotation, objects include planes, balls, and missiles. All of them are deflected from the straight line. The wind is also deflected to the right in northern hemisphere and to the left in southern hemisphere. So the magnitude of deflection is very small by the equator and great around the pole. Also, because we are directed towards low pressure and because air rises in a low pressure area, stormy weather results as the water reaches its condensation point in the atmosphere. This one results in cloud and precipitations. Thank you. Let us discuss another important causes of weather, and that is cloud. Cloud is a large collection of very tiny droplets of water or ice crystals. The droplets are so small and light that they can float in the air. The process of forming cloud starts when warm air rises due to evaporation, as discussed earlier. The water vapor ascends gradually to the sky and starts to swell and cool. It then forms cloud gradually. This water vapor becomes so many that they begin to form together, such that when sunlight shines on them, they become partially impervious and therefore they reflect sunlight. And when you look up, you see a white cloud. And that is the reason why you see that white cloud. But it can also come in dark or gray clouds sometimes. This is because the sunlight is scattered in all directions instead of being reflected. And that is why you see that cloud. There are different types of cloud. And of course, there are cumulus, cirrus, stratus, and nimbus. But again, each of these clouds are identified or classified according to height. Of course, for the high clouds, those ones that are very high, they are known as cirrus, and they are usually above 15 feet. And the type of cloud you meet in that surface is cirrus, cirrostratus, cirruscumulus. The middle clouds are all those that are between the 6,000 feet and 18,000 feet, and they are known as alto. And of course, what's the cloud type you see there are altostratus, altocumulus. Next are the low clouds. The low clouds are those that are from the ground level to 6,500 feet, and they are known as stratus. And the cloud you find there are stratus, stratocumulus, nimbostratus. Now, there are also some clouds with vertical growth. We have the cumulus and cumulonimbus. I will leave the detail about the study of cloud till a special lecture that I will do next. But however, it is important that we look at some of the interesting facts that you don't know about clouds and some of the knowledge you need to have so that when next you see cloud, you are not surprised about what you see. Do you know that cloud can also be formed on ground? And you have probably seen the cloud before on ground and you are not aware. The cloud formed on ground is called fog. So the fog that's lower in visibility and all that are the cloud formed on ground. You see, the formation of cloud itself is due to the condensation of water vapor, resulting from the rising of warm air to the air surface, like I told you, and consequent cooling down of water vapor, And sometimes in one of the lectures I will discuss, we can have an inversion of the situation, which is called temperature inversion, in which the temperature up will be higher than the one lower. And this is exactly what causes fog. Sometimes all clouds you see in the sky, you may think they are all clouds. Some are not actually. Some clouds come from airplane. The exhaust of airplane emits some cloud called contrails. But some of these clouds sometimes are put together on purpose by a mixture of a particular type of chemical. Most especially for some special occasions like military anniversary parades. I hope you enjoyed this lecture and sincerely wish that you will subscribe to my channel to encourage this type of lectures as we uncover physics in the most simplest and interesting way possible, as well as study our universe and to be well equipped with the tools or to survive this complex world. Thank you very much for your attention. See you during the course of next lecture.